Hello. Hello students and welcome to this video. In this video, we will solve question number 131 to 140. So when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. Or you can leave the question and come back later. So the link to download the algebra and trigonometry book both will be in the links, and you can use that to download both the books. So question 131, without further ado, let's get started. Question 131 says that in how many ways 50 pearls can be arranged to form a necklace? So in a necklace, clockwise and anti-clockwise direction does not matter. The total number of necklaces that can be made using 50 pearls is 49 factorial over 2 factorial. Question 132 says that a round table conference is to be held between 20 delegates of 20 countries. In how many ways they and the host can be seated if two particular delegates are always to sit on the other side of the host? So when you have two particular delegates, you treat them as one delegate, and you have 19 delegates which can be seated in 18 factorial ways. But two delegates can be seated in 2 factorial ways among themselves. The total number of sitting arrangements is 18 factorial multiplied by 2 factorial. 4 gentlemen and 4 ladies are invited to a certain party. Find the number of ways of sitting them around the table so that ladies are seated on the two sides of each gentleman. So this is essentially alternate seating arrangement. So first we seat the gentlemen. So we seat 4 gentlemen in 3 factorial ways. That will give us 4 open positions, and women can be seated in 4 factorial ways in those 4 open positions. The total number of arrangements is 4 factorial multiplied by 3 factorial. Question 134 says that in how many ways can 7 Englishmen and 6 Indians sit around the table so that no 2 Indians are together? So 7 Englishmen can be seated in 6 factorial ways, giving us 7 open places which can be filled by 6 Indians in 7p6, that is 7 factorial ways. So total number of seating arrangements is 6 factorial multiplied by 7 factorial. Question 135 says that if 15c3r is equal to 15cr plus 3, we have to find r. We know that if ncx is equal to ncy, then x is equal to y, or x plus y is equal to m. So either 3r is equal to r plus 3, or 3r plus r plus 3 is equal to 15. If we take the first condition, that is 3r is equal to r is equal to 3, r is equal to 3 by 2, which is not possible. Therefore, 3r plus r plus 3 is equal to 12, that is r is equal to 3. Question 136 says that we are given nc6 is to n minus 3 c3 is equal to 33 is to 4. We have to find that. So in this case, we write the combination formula. nc6 becomes n factorial by 6 factorial multiplied by n minus 6 factorial, and n minus 3c3 becomes 3 factorial multiplied by n minus 6 factorial divided by n minus 3 factorial. So n minus 6 factorial will cancel out, and what we will have is n into n minus 1 multiplied by n minus 2 divided by 6 multiplied by 5 multiplied by 4. That is 33 divided by 4, which is given. So we get n into n minus 1 into n minus 3 is equal to 11 and multiplied by 10 multiplied by 9, that is n is equal to 11. Question 137 says that find the value of expression 47c4 sigma j is equal to 1 to 5, 52 minus jc3. So we expand the sigma, we get 51c3, 50c3, 49c3, 48c3, and 47c3. Now we know that NCR plus 1 is equal to n plus 1 CR plus 1. So we combine the 47 one, we get 47C4, 47C3. This gives us 48C4. This should be here. And in the next one, we will add 48C4, 48C3. this should not be there. This term is already taken care of. It should be 48C3. And then you repeat this, eventually you will get 52C4. So there are two typing mistakes in 137. Question 138 says that prove that the product of R consecutive integers is divisible by R factorial. So we take R consecutive integers as n into n plus 1 into n plus 2 up to n plus R minus 1. So now we take this product as P by R factorial is equal to n multiplied by n plus 1 multiplied by n plus 2 up to n plus R minus 1 by R factorial. Now we multiply this numerator with 1 multiplied by 2 multiplied by 3 up to n minus 1, and we divide by that as well. So what we have on the top is n plus r minus 1 factorial, and in denominator we have n minus 1 factorial multiplied by r factorial, which is n plus r minus 1 cr, which will be an integer, and hence p is divisible by r factorial. Question 139 says that find the number of triangles which can be formed by joining the angular points of a polygon of m sides as vertices. So a triangle is formed with 3 vertices, so the problem is essentially about choosing 3 out of m, that is mc3, which is equal to m into m minus 1 into m minus 2 divided by 6. Question 140 says that a man has 8 children to take them to a zoo. He takes 3 of them at a time to do as often as he can without the same 3 children going more than once. How many times will he have to go to zoo? How many times a particular child will go? So number of ways of choosing 3 children is 8C3 ways. So the man will have to go to zoo 8C3, that is 56 times. So number of selections of 3 children out of 8 children, including a particular child, is 1 multiplied by 7C2 is equal to 21. Hence, a particular child will go 21 times to the zoo. So with this, we come to the end of 140 questions and 14 set on permutation and combination. In the next video, we will solve problem number 141 to 50. And I have one extra thing to talk about, that is about quadratic equation. There is a new technique I have learned, and I will show you in the next video. So the link will be in the description, but if you want to see the website, this is my website. You can download Algebra and Trigonometry book directly from here, and coordinate geometry book should be available within 20 days. So the date here will indicate that when the book was updated. YouTube link will not have the update. Okay. So with this, we come to the end of this video, and I hope that you are enjoying this video, this entire playlist. If you have not gone through the playlist and you want to revise your other topics, you can go through entire playlist. And thanks a lot for watching the video. I'll see you in the next one. Till then, stay curious.